Hello and welcome back. In this video, I'm going to provide a demonstration how to implement a stack, a linked list stack using a C language program inside an IDE like CodeBlock is. Now I'm going to share my screen. Here I am in CodeBlocks, and now I'm going to create a project, file, project, console application. I'm going to use the C language, English to download, CPRA. I'm going to create a folder. Say stack example. Predicted title project. I call it stack sample. Well, example. Next, my compiler. Finish. Okay. Let's see. The first thing I have to do is to create the declaration of the nodes I'm going to use. I'm going to declare an struct node key, and this node key is going to be the structure I'm going to use for my nodes. And inside my structure, I'm going to create my elements called char name. I'm going to make a name of length. I'm going to use max name length. Here, I'm going to declare. I'm going to define, sorry, max name length equals 15. Now I'm going to define a second variable, a second element, my int integer age, integer age, and that's it. And now I'm going to define a struct node t pointer. I'm going to say pointer to the first node. Struct node t pointer to the last node. Sorry, previous pointer to the next node, pointer to the previous node. And I'm going to create a variable called temp node. This temp node is going to be a variable to keep values for the new nodes and to the new nodes to push into the stack, and the nodes to pull from the stack. Okay, now I'm going to create a type definition. Type def struct node t pointer node, and I'm going to create a pointer to the first node. Going to be pointer node type pointer first node equals node pointer to the last node pointer last node equals node. Here I'm going to write down some explanations for future. Structure no, or no definition. Definition. Maximum length of the names. Okay. Now I'm going to declare the functions I'm going to use. And the functions I'm going to use in the stack mainly are the push and a pull. I'm going to create a function, declaration, so I'm going to create a push, a boolean, push. I'm going to use a pointed node, pointer new node. I'm going to create a boolean, pull, pointer node, pointing new node. Okay. I'm going to create. I'm going to write what these functions do. This function pulls a new node from the stack. Input parameters, pointer node, pointer new node. It points to the values of to the elements before in the new node. And output is going to be a boolean error. I'm going to say boolean error, and this is going to be a variable, a returning variable, to tell me if there was an error or not when the function was executed. So 0 is going to be if there was no errors, and 1 is going to say there was an error. This is going to be very useful to deal with my errors inside my program. Now I'm going to define something similar to the pull function. Pull a new node from input parameters, pointed to new node, points to elements to points to the elements to keep the node. And equals, I'm going to use a returning variable to say if there was any errors in my function. Okay. And now I'm going to just place this one, and I'm going to copy all this declaration, and I'm going to define the functions. The first thing I'm going to do is to define a variable with direction zone. I'm going to create the variable I'm going to use as a returning to return the value in this function. Bool error was 0 because at the beginning there are no errors. Return finish the function. Return 0. Okay. Now I'm going to check when I'm going to push an element. I need to know if the stack is empty or not. So check if the stack is empty. If I pointed to first node was a null, that's it. It means I have to allocate memory in the first node because the stack is empty. The stack is empty. So allocate memory for the first node. So pointed to the first node equals pointer node. So I have to cast the pointer of the memory that I'm allocating. Malloc to allocate memory, size of struct node T. Now I'm going to check if the allocation was successful. Successful. If pointed to the first node was null, it means the allocation was a fail or failed. It means error. So error equals 1. It was an error, and change the function. The function, yeah, and return error. But if there was no errors, I have to first thing I have to allocate to assign the last the pointer to the last node, and here we have to say in the empty stack the first node allocated node equals the last node. So I have to say pointer to the last node equals pointer to the first node. And I have to say in the first node, remember I've created a node type where we have two elements to store data, name and age, and I've created two pointers, a pointer to the previous node and a pointer to the next node. The next node, in any case, after create the new element, the next node is going to be null in any case. But in the previous node of an allocated a new node depends if the new node is the first node or is not the first node, because the node allocated is the first node. The previous node is going to be null because before the first node there is nothing, there is any nodes. So the previous node has to be null. And if not, if the new node is not the first node, then the previous node has to be assigned to the previous node. So in this case, I'm typing what happened when I'm allocating memory for a new node, and this node is the first node. So in this case, assign pointer to the previous node. In this case, pointer to the first node points to pointer to the previous node equals no. Let's check if there is any errors. Oh my, there was a lot of errors here. Because I forgot to write a semicolon here. Okay, no errors now. Don't worry. Okay, I've checked if the stack is empty, and the stack in this case was empty. But what happened if the stack was not empty? Stack was not empty. So I have to allocate memory for the new last node. So it means there was, if the stack was not empty, it means there was a last node. I'm going to name this last node as the old last node. Okay, I'm going to repeat. I'm going to name the last node as the old last node, and the node I'm going to create as the new last node. Okay, this is important to understand all I'm going to explain now. Okay, I'm going to allocate memory for the new last node, and I'm going to say pointer to the last node that it is the old last node that points to the pointer to the next node is going to be equal to pointed node size of struct node D. Okay, and this is the old pointer to the old last node, and all this is the pointer to the new last node. It means pointer to the new last node has going to be allocated. I'm going to allocate memory for this new to the pointer to the new last node. Okay, I hope it's clear because it's a bit confused. Now I'm going to check if the allocation was successful. Check if the allocation was successful. Okay. If pointed to the last node that points to the next node, that all this is the pointer to the new last node. Well, the null, it means there was an error. So the allocation failed. So error equals 1, finish, function, return error. But if there was no error, so the allocation was successful. So what do you have to do? I have to do the same as I did previously. I have to allocate the new last node. So I'm going to allocate first the previous node. Okay. The previous node in the new last node has to be the pointer to the old last node. So pointer to the last node that points to the next node that points to the pointer to the previous node, equals last node. I forgot to put pointer. Okay, let's review this sentence because this is a bit complicated. This pointer is pointed to the old last node. All this is pointer to the new last node. And pointer to the new last node, I have a pointer to the previous node that was the pointer to the old last node. So in the last node, I'm pointing to the last node. Now I'm going to set the pointer okay, set the new last node. Pointer to the new last node. So pointer to the last node equals a pointer last node that points to the next node. And now the last node and the previous node, the last node is set, and the pointer to the previous node in the last node is set as well. And now I'm going to push. I created the last node in any case, the stack is empty, and the case the stack is not empty. I'm set what is pointed to the new last node, and inside the new last node, I've set the pointer to the previous node in any case. So now I have to push to store the data from the pointer new node to the new node. Okay, so I'm going to store first the name, but I have to use the string function encopy because I can't copy two strings using equal. I have to use this string function. I have to say pointer to the last node name, pointer was pointer new node, pointer new node that points to name, and I'm going to limit this copy to max name line. Now I'm going to store the data, the name. Here I'm going to say the name. I'm going to say the age from the new p node. Point to the new node to the pointer from the pointer the new node to the new node. Okay, I'm going to say pointer last node age was pointer new node age. Okay, now I have to update the pointers to the next node, pointer to the next node. Okay, but the pointer to the next node. Pointer last node. Last node points to pointer next node. False and null, because in any case, one time, once I've created the new node, the pointer to the next node doesn't exist. So it's equal to null. It's equal to null. I think it's all I have to do. Let's check if there are any errors. String copy, because I didn't include string library, and I didn't include the malloc.h, the malloc library. Going to check, no errors.